Okay, my friends, I have some extremely disturbing news today. This is about global warming. Now, they're starting a new institution here in the United States, apparently, the U.S. Greenhouse Gas Center. All right, they want to know about this greenhouse gases, how it's affecting our environment, and they're showing crop failures and all kinds of different interactions of the weather and so forth. I'm just going to let this play for 1 second, then I'm going to tell you how devastating this is. Now, I turn the sound off, but they're showing crop failures and flooding and all kinds of different things are happening all over the earth. Now, what I want you to watch is this. Look at this. What is this all about here? That is our atmosphere. All right? This is the greenhouse gas beta version of the U.S. Greenhouse Gas Center. They want to understand these greenhouse gases, and they have all kind of data sets, and they're really doing research. Well, I'm going to tell you something right now. They do not understand global warming. It's not just the carbon. They think they can get the carbon out of the air and everything will be fine. No, absolutely not. It's the expansion of these gases. They're way out here now. They're scrubbing harder and harder into the atmosphere. That's what's causing the global warming. It's getting hotter out here. Way out here. It's over 2,000, 3,000 degrees out here. People don't understand it. It's so hot out here, and then it gets extremely cold below that because it's a dipole. So the hotter it gets out there, the colder it gets below. The colder it gets below there, the hotter it gets down on the surface of the earth. That's what it boils down to. It's layering of cold and hot. And we are in the bottom hot layer, and then the earth absorbs all that heat. That's the way it works, and they don't understand this. And they will never understand it, and we will never overcome global warming until they start to listen to what makes sense. This is not a vacuum. This is not an empty space out here, and they know it's not empty. Obviously, we're scrubbing through it. It's unbelievable. Okay, once again, their claim versus my claim. They say that if there's more carbon here, the carbon attracts more molecules, heat molecules, and they won't let them just drift back into space like they normally would. Well, that's not correct at all. The carbon will hold heat, yes, absolutely. But the carbon is a product of expansive gases when you burn something. So in other words, when you burn something like this, where it was on Earth, now it's going to be like huge. It's going to be gigantic like this, a big ball of gases. This is what's happening. Instead of this staying the same size, this is getting bigger and bigger and bigger. And the more we burn and the more fires and the more oil we pump and the more combustion on Earth, everything that we burn turns into gases. This is scrubbing all the gases in space. This is not empty space. It's saturated. Watch the effect now. Just think about it. Just use your mind. Watch what's happening to this atmosphere. Why do you think it's getting all in turmoil? Watch. I have this running very, very slow. What's pushing it? Why would it do this? Why is this all about? It's because it's forcing its way as it spins. We're not showing it spinning, but it's moving forward and spinning at the same time. And it's scrubbing harder and harder and harder as it gets bigger and bigger and bigger. And that's why we're getting these huge waves and plumes of gases and huge moving atmospheric waves through the atmosphere. It's a disaster, and they don't understand it. They think this would just drift off into space if we could just get that carbon back, we're all set. No, absolutely not. It's the expansion. We got to stop burning things. You can't take something this big and turn it into something the size of a house, because that size of a house keeps expanding our atmosphere. It's as simple as that. Okay, my friends, as you're going to see, I have a bit of an attitude about this because it's so obvious. I can't believe that it's not understood. We are scrubbing through the universe, spinning, scrubbing our atmosphere, which is out here, which is this atmosphere right here. As we go spinning and pushing through space, the same as the sun. They have an atmosphere here too. It's called the corona. We have an atmosphere. It's called the ionosphere. Our ionosphere out here, which is right there, is almost 3,000 degrees. Way out here. All right? It's because it's scrubbing. It's scrubbing 3,000 degrees out here. 100 and so, it's over 100 now on the face of the planet in most cases. Now, these are the poles. And I can tell you that for certain because this is where its impact zone is, and that's the other impact zone. We're spinning this direction. And this is spinning in this direction because this is the leading impact zone. And I can tell that because of the separation of the gases. Here it's the trailing and it's coming off this way. Here we're pushing in and spinning into it. The same as the sun. Now let's take a look at this carefully. All right, you see this here? And here's you can see the clouds are being lit up by the sunlight coming in. This is the side facing the sun. The sun is literally burning this layer of our atmosphere and forcing all these particles down onto us. That's what sunlight does. It just does it. That's its nature. And this is a range where it's being hit very directly by the sun. This side of the earth is not being impacted at all. It's the trailing edge and it's in the darkness. So you don't see this fine separation here. It's just all one glowing layer of heat. This is extreme heat and this is less heat, but it's a dipole. So out here it's about 3,000 degrees above zero, 3,000. And right at this layer here, it goes down to minus 112. That's over 3,000 degree temperature difference right on this polar line. And that's because everything is a dipole. So here's what happens. We're spinning through space. The very edge out here gets hot as it can possibly be, 3,000 degrees. The dipole nature of heat and light means that the other side of the heat will be the cold. That's where the minus 100 degrees is, right next to it. And then below that will be heat again, and that's right on top of us. And then the earth is the ground that will take all that stuff in. But it doesn't just take it in and nothing happens. The oceans get warmer. The land gets warmer. The mountains get warmer. The globe, everything melts. The heat just rises and rises and rises. And the more we explode our atmosphere from greenhouse gases, the harder that scrub will be. And that is what's causing it right now. This is the poles, and this is where the vortex, where you can figure out what's going to happen in the weather. But you see the difference between here, and up there? That's because that's the pole. And the same thing we can see happening on the sun. Now the sun is, when it radiates, it is so radiates so strongly that most of the particles, when they leave, when they get to about here, they're gone. They're never coming back. Now in ours, they get out there, but they can't leave. Here, and the ones that are here, they're pulled back. And now I can tell you another fact of how the sun is moving. This is a solar eclipse, and the sun, moon is obstructing the blinding light. The sun itself is behind the moon. That's the poles, North and South Pole. When anything spins, it has poles. This is the impact zone here. It's spinning this direction. So as it goes this way, pushing this way through space, these are the impact zones, and these are the exact areas you would expect to see, because this creates a field in the center, a very strong field. Then the next one sets up here, this one sets up here. The red spots are the most intense area. Once it gets out here, it's millions of degrees. It's 10,000 on the face of the sun, 10,000. Out here it's millions. Out here it's millions, and guess what? Bennu, that they just came back with a sample from, has basically the same chemistry as they say the sun has, which was of extreme interest to me. So before we get started, this is my claims. They show this picture. I agree with it 100%. These are the temperatures. out here, well, I don't know if I showed you this, but here's what happens. The Earth spins through space, moving this way, and everywhere it scrubs, it's extremely hot, and it's all negative ions out there. They're just basically the negative part, the white part. And just below it is the black part, the dark matter part, mostly. And that is when it gets real cold. So it gets real hot, real cold, and then hot again, and then the Earth absorbs that energy. So that's why it's 3,000 degrees out here. Millions for the corona of the sun. Same reason. It's scrubbing, and its outside atmosphere is scrubbing through everything out here. And if you think this is empty space, there's something wrong with your mind. If you think this is a vacuum, you're out of your mind. Plus, light itself is particles. I've shown this, and you're going to see it again. If they think that the light coming from there is all traveling at the same speed, nothing ever slows down, and that accounts for the red shift and everything's being pulled away, that's insanity. Literally insane. I can't believe anybody there is that incompetent that they don't realize this. And they're touting, well, we just found the furthest galaxy in the world. Well, who says it might be right behind here? And it just got real slow coming through. If it's empty space, yeah, if there's nothing there, but there is nothing, there's nothing. And even Fermilab says that, right here, quantum foam. Empty space isn't empty. All right, it says that the empty space experiences similar activity as the bubbles on a root beer. Subatomic particles, these are the little particles that I'm talking about, winking in and out of existence as they get hit with other light particles. These little particles, subatomic particles, are real and have a measurable impact on our universe and the light traveling through it. It's slowing down. They agree with it. They understand this, and they've understood it for a number of years. This is 2013. And they also see the same particles that we found are these particles right here, the black and the white, red. But they're trying to smash huge protons together and getting little bits and pieces, and they say these are the smallest pieces we can find. Well, guess what? This is made out of this, and this is made out of one of these. It's a magnet. It's a dipole, a positive and a negative. And the positive has all the weight and the negative has all the energy. And when you put 1,823 of them or so together, you end up with a proton. So when they smash into bits, yeah, they see these. But they also see things like this. And they see things like that. And they see things like this. They see things like that. And they say, oh, it's a particle zoo. No, it's not. It's just pieces of the same particles put together, and this is what it is right here, dipole electron flood theory. This is what a proton is. Right there. All the dark matter goes to the center, all the glowy parts go around the outside. You'll see, I think I got a lot more coming up on this. Okay, my friends, I have a major dispute with this curated, trusted greenhouse gas data. This is the new greenhouse gas center that they're coming by the U.S. GHG Center website. Now this is California right here, and up here is the pole. Now let me show you what they are showing as the weather interactions and talking about how they're going to address greenhouse gases. Well, here's the thing. You see this layer right here? You see that? See how perfect that is? See how perfect that is and how fuzzy this is? And then you got all this globby stuff up here. Well, this is because the Earth is spinning. And it's impacting at the pole. The poles are the vortexes. Here is just up here. So this is where the weather is being emanated from. These are impact zones. Look, just take your time. Take your time. Look at it carefully. This is the Earth. You see this zone from here to here? That's our atmosphere. That's the atmosphere here. Well, why is it so much different here than it is here and here? The reason is the globe is spinning in this direction, let's say. And these are the impact zones. All right, this is just barely tickling around a little bit. These are, and this is going, so up here, all the gases are being converted up into this area, and then they're going to turmoil. And then they're going to be sent down back, which is what you see here. Now, here's my allegation. All right, now take your time. I'm going to focus in a little closer so you can see this better. This is what I say is happening. You see this zone right here? That is a zone of extreme heat. And you say, oh, no, it's got to be cold out there. No, absolutely not. This is the ionosphere out here. You see that? And you're going to have one of them that's going to be really glowing. And I believe the Earth is spinning in this direction. So this impacts this way. So more energy is being crushed into this atmosphere than here. This atmosphere is trailing off. So if the Earth is spinning in this direction, this leading edge is going to be going and creating this separation zone. You see the separation zone there? Take your time and look. You see that separation zone? See how it's really light here and then it gets heavier here? Well, that's exactly what would happen. Now, on the other side of the Earth, which is trailing, you don't have that. Because this is basically the nighttime side, is the way I'm seeing this. This is where the sun is hitting it. And this is where it's just in the dark and coming back around. And this is the spinning into the sunlight. And the sunlight is going to create all kinds of additional particles forcing themselves, and they are forced in. This, see this line? I mean, it's very, very crisp. Hold on. Well, this side is crisp too, but so is this one. You see how crisp that particular line is? You see that? This is nothing but particles out here. It's scrubbing just like it's crushing into a road. This is forcing the particles in. They're not just going to drift out into space. They have the whole thing backwards. They have the whole thing backwards. They don't understand the particles are being forced in this way, and the whole reason is for this global warming. It's just going to get extreme and just way out of control very, very shortly, because as this expands out this way, and it will, because of all the burning, things that were solid are now gaseous, and not only are they gaseous, they're literally hundreds of thousands of times bigger than they were when they were particles glued together inside the Earth, which is all your fossil fuels and all that stuff. And when it comes out of there and they burn it, it blows like light. It's just a balloon. And this layer right here is our atmosphere. I'm going to get in deep with this, very, very deep. I'm going to show you the levels of temperatures, particulates, the scrub. The temperatures out here is almost 3,000 degrees. 3,000 degrees, why? Should be cold. Down here it's minus 112 degrees. From 3,000 down to minus 112, and then back to up to, now it's over 100 in most places. And then you take the Earth, and the Earth absorbs all that heat. But that heat only goes this way, it doesn't go that way. Okay, in order for you to understand what I'm saying, you have to understand what they're saying. They're talking about carbon dioxide, CO2. Here's their take on global warming, is the carbon absorbs heat, and it just keeps absorbing the heat and won't let it radiate back out to space. Well, it won't radiate into space. Here's what they're saying. The CO2 absorbs infrared energy from the Earth's surface and re-emits it in all directions, including back towards the Earth. It just heats up, basically. Process is similar to putting a blanket on and trapping the heat. So it's actually absorbing the heat. In other words, the more CO2 molecules in the atmosphere, the more heat they can trap. Well, what it is the heat will not radiate back into space. It doesn't go into space. It just keeps getting more and more pushed into the Earth. And the reason is because the atmosphere is expanding. Let's look at this one more time. And I'm going to show you the temperature differences. It's undeniable once you take a real look at it and understand it. If you think that's empty space, there's something wrong with your mind. This is what the whole entire universe is filled with, is particles. And every particle has a field surrounding it. Every single particle. The bigger the particle, the bigger the field. Look at this. This was taken with a cell phone. These are all fields surrounding stars, surrounding whatever it's surrounding. They're actually magnetic fields. Any light that passes through there is going to be suppressed. It's going to be slowed down. We are literally lost in space. And you can see, look at this. This is what, again, we're taking with a cell phone. That's the moon. And this is the Pleiades, the seven sisters. And they have all of these fields surrounding them. Everything has a field. And here's the sun. As it cascades through the universe in our solar system, it's spinning like this. And I know that for a fact because this red here is spinning this way. This is a solar eclipse. So this is the moon. And it blocks out the blinding light. So we can see what's being given off. This is hot as hell, hot as hell, hot as hell. And the reason is it's spinning this way as it's moving that way. So it's spinning into the atmosphere, which is out there. There's a huge atmosphere. And it's spewing out all these particles because it's overheated. The sun is gigantic compared to everything else. Now we're spinning through, and you can see all that turmoil and all that stuff. We're heating up, but the sun is so hot it just combusts. This is all combustion gases. And this is the trailing gases, and this is the forward-leading, spinning into gases. And here's what it looks like as it's moving through space. This is what we actually look like when we're moving through space. We're spinning on the arm of the Milky Way. The sun is spinning this way. All right? We're spinning around the sun. We're not on a flat plane behind the sun. We're trailing the sun, trying to catch up to it. And the whole galaxy looks like this. And we're on one of these arms coming around this way. Now, there's a lot of variation here, possibilities. We could be coming through some real dense space because everything's moving forward. Whatever's in front of it, you got to get through. Now, if you're coming through something here that there's just nothing hardly in front of it, well, there's less pushback. But if you're coming through a dense place in space, you're going to be pushed back against. What does that do? It heats things up. What does that also do? It slows light down. And this is no question whatsoever. We can speed up and slow light down. And we have found the same particles that Fermilab found, only we found them using light instead of gigantic particles like protons. We used the particles of light, which a proton is actually made out of this, and they're all made out of these two dipoles. Light is nothing more than the tiniest bit of a proton. All right, they're trying to find light. Well, light comes out of a proton when they smash it, but it's unbelievable. The people that are running science, it's incredible. I've tried, 10 years I've been trying to talk to the Fermilab about this. 10 years I've been trying to talk to NASA about their stories, about literally everything they're talking about is wrong. Mars is saturated with life. Saturated. And so is Earth. The geology we've been taught is wrong. The science we're taught is totally wrong. Physics is totally wrong. Chemistry is wrong. The periodic chart has to change. This is not a proton. I mean, this is a proton, not one of these. So hydrogen is not one. Hydrogen is about 1825. We got a lot of work to do, and not a bit of it will be responded to. I've been talking to all the top places in the world about my research that totally dismisses their research, and they refuse to engage because they, at this point, I'm not going to say what I think about them, but it's obvious they're not being honest with us. This is 2013. I showed them our particles just shortly after this. And they also agree, this is Fermilab. These are the two particles they show, and they do exactly the same thing that they talk about. The white one here, the glowy one, can get big, it can get small. The black one never changes, a fixed size. It's got all the weight. And again, I show that right here. Here's the same particles. This one gets bigger and smaller, smaller and bigger, and the black one never changes. Not only that, we actually created fission and fusion. We created the black and the white separated, and they came back together here. That's called muon neutrinos turn into sterile muon. Electron neutrino turn into electron showers. We did this. We accelerated light. We slowed light down. We split light. We refused the light. We've done everything that Fermilab and CERN and all those wanted to do. And they refuse to engage because they know they're all wrong. Empty space isn't empty. They know this. The same thing back to 2013. It's filled with particles winking out of existence, subatomic particles winking in and out of existence. That's because they're all out there. They're just laying around, and when they get hit with something, they glow. These are just laying around. They don't glow until they get hit with something. These are glowing because they're rubbing through, so we can see them glowing like crazy. But everywhere in there, everywhere, not a single inch is missing particles. But they're light that just has no glow to it because it's not being popped. That's the difference, and they just cannot get their heads around this. This is the issue with global warming. Out here, the exosphere, there's not a ton of particles out there. It's kind of, they're there, but they're not a ton of them. But we're scrubbing through them. And then there's going to be a layer right there, which is the ionosphere, that says, I'm scrubbing through you. You're trying to push your particles into me. I'm scrubbing you. My particles aren't going to go this way. You're going to come into me. And that's when it heats this up hotter than hell. Out here, they think it's real cold. It's 2,700 degrees out here, 3,000 degrees, somewhere around there, and it's getting hotter and hotter. What happens then? Right below it, it gets cold. It's minus 80 degrees. That's 112 below zero in Fahrenheit. So it goes from 2,700 above to like 100 and something below. This is thousands of degrees difference. And it's borderline because it's a dipole. You got hot, you got cold. Then you got hot again. And that's where we are. And then the Earth sucks it in as the cold. This is going to just keep getting hotter and hotter and hotter. And the ice coming out of the mesosphere here, which is the cold layer, is getting bigger and bigger and bigger because it's getting colder and colder. They think it's getting colder, so there's no problem. No, it's getting colder because it's getting hotter out here. The hotter it gets here, the colder it gets here. The colder it gets here, the hotter it gets here. The hotter it gets here, it is us. That's what's causing global warming. It's so obvious, it's unbelievable they can't get their heads around this. Absolutely incredible. Just look, just use your mind. I don't know what to say. I don't know what to say. How these people can spend $20 billion a year and not even have the slightest idea what they're doing. Not even a clue. Out here, they're scrubbing through all this stuff, creating that heat, forcing it in here. And the hotter it gets out there, the hotter it's going to get down here. That's global warming, my friends. All this data set nonsense is just a big expense and not doing the job and not understanding. And that's what we have right now. No understanding. So this is, I mean, it's just so obvious. It's unbelievable. This is what's happened. And the same thing's happened to the sun as happening to us. Is another thing. They want to spend billions more dollars to go out and try to figure out why is the sun's corona out here so hot. Same thing as why our exosphere out here is so hot, because we're scrubbing. The sun is scrubbing too, but it's scrubbing much hotter. It's millions of degrees out here and only 10,000 on the surface. Millions. There's no explanation whatsoever. The only explanation is that all of the things that are radiating out are scrubbing through the space, just like all the things that are in us are scrubbing through space. Now, the sun is much more intense, so it radiates and it breaks out and they get out. We're not intense enough. We don't break out. We stop about here. Almost all. Some of it gets out, obviously, but not much. The intensity, in other words, the sun is putting out stuff way, way, way off to this end of the spectrum. We're putting stuff out, you know, visible light, basically. What are we putting out of here? Visible light. We're not putting out X-rays and gamma rays. We don't have a machine shooting that out. So we're putting out about visible-ish light, and it stops here. That's it. It's going to be pushed back in by all the ultraviolet and X-rays and gamma rays coming down from the sun. That's what happens out at the outer atmosphere, is that interchange. It's not going to just blow off into space and cool us down. No, absolutely, je ne sais pas, will not happen. Never going to happen. The only possibility we have in the world to stop this is to stop the expansion of these global gases, and I don't think there's any way to do it now. They keep saying, pump, baby, pump, 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 get some more oil on the ground, which is stuck down there. It's not expanding. As soon as you pump it out and burn it, we're blowing up like a balloon, my friends. Okay, this is why we're in such trouble. How exactly does carbon dioxide cause global warming? This is from Columbia Climate School. Climate, Earth, and Society. We're going to fix everything. Well, You Asked is a series where Earth Institute experts tackle reader questions on science. Well, I can tell you what, they have no idea what they're talking about here. How does carbon dioxide trap heat? You've probably already read that carbon dioxide and other greenhouse gases act like a blanket or a cap, trapping some of the heat the Earth might have otherwise just radiated right back out into space. No, it does not radiate out into space. It's being scrubbed down. He says, that's a simple answer. Well, yes, it is. How exactly do certain molecules trap heat? The answer there requires diving into physics and chemistry deeply. Wow, this is going to be fun. This is the State of the Planet, news from Columbia Climate School. How exactly does carbon dioxide cause global warming? Now, they go into exactly, look how deep they get into this. First of all, they talk about the radiation and the blanket effect and all that stuff. It's mainstream. And then they're talking about different frequencies and radiation coming from the sun into our atmosphere, and why does the carbon absorb more heat? And then they're going to go into how can you actually see this in experiments. This is where I'm going to get deep into this. And they got a couple of experiments going, a more logistically challenging experiment. They're going to show this with a candle on one end and something else on the other end. And I am going to explain exactly what they're saying. Look at how long, look at the size of this article. This is going to, well, down here, this is what they're talking. There's responses. Let's see if they'll respond to me. I doubt it. I've never had one response from anybody in academia to any of my stuff. NASA, Fermilab. Well, Fermilab did respond. We got in a big, gigantic argument, me and Don Marino. No, I'm sorry, Don Lincoln. And I showed the same particles he showed. They just refused to deal with reality. These are the particles from Fermilab. And here's our particles here. I said, these are here. They, no, oh, you can't see them. It's impossible. You're a crazy guy. And really, basically, he said I was a tinfoil hat guy and don't contact me again. This is the kind of stuff I get from academia. And I'm showing the evidence that crushes them, literally crushes them. And this is why they won't respond. It's just arrogance and it's all about them. Everything is about them. It's not about the reality of the truth. It's about them. You know, it's not really in my nature to be nasty, but I do find myself being nasty towards NASA and Fermilab and Yale and all of them that just won't listen to anything other than what they dictate. And they are dictating. This, when they went to Bennu, I already knew what it was. It's a heart. There's no question whatsoever. These are muscle sarcomeres they came back with. These are phosphates, which are from membranes, which has the phospholipid membranes. Phosphates, they had, wow, we never expected this. And they never expected muscle sarcomeres either. Now, this was from a video I did, I don't know, a week or so ago. Muscle fibers, membrane phosphates mysteriously found in asteroid Bennu. I've tried to contact all these people over and over, and they cut my videos out. They're not being displayed anywhere. I get very, very few hits on these things because they just go against what everybody says. Okay, my friends, space is saturated with particles. Even Fermilab says that. All light are particles too. I showed you what light is. It's particles. It's everywhere, and it's just, it doesn't do much. It's coming towards us until it bangs into our atmosphere, and that's where we're getting really slammed, right here. And it gets hot, extremely hot, where we scrub as we're rubbing this way and spinning around the sun. So there's a real heavy-duty scrub right at that surface. So out here, whatever particles are out here, and it could be dense at times, it could be not dense at times, it depends, because we got to plow through whatever the sun is shedding back at us, because we're trying to catch up to the sun. I think I showed you this thing here. All right, all these particles coming off the sun, we have to plow through. They call it the solar wind. Well, it's the particles, and the particles are right here. Hold on. Whoops. The particles are here. These are all particles. And some of them are big chunks. They're not just all tiny little light particles and dust and so forth. Some of them are pretty good size. Most of the big stuff comes back. Most of the big stuff comes back. But the really, that's gone. That's not coming back. And of course, that's the pole. And the sun is going that way, spinning this way. That's why heavy scrub, heavy scrub, heavy scrub, shedding. Moving this way, turning that way. You know, I just want to say something. The things that I present are big, broad things that show exactly what I'm talking about. They're not innocuous little, silly little things like, oh, the spin is 2 degrees to the left of dead zero or some crazy thing like that. I'm showing you the particles. All right, I'm showing the actual particles. This is not just some drawn up stuff. And this is light accelerating. This is actually a photon. These two are the particles that CERN and Fermilab find, but when they smash them, they just have gigantic balls of debris. We can actually see them coming from lasers. And when they do, they can actually split the black from the white. That is fusion and fission, fission and fusion. Here they're fused together. That's what they're supposed to be. They're not supposed to ever break apart unless you put them through a particle collider and crush them and smash them to bits. And that's what we did. This Venturi is so small that the white, being able to squish down, can squirt through. The black can't squirt through. It's the same size, never going to get down. The white, let's say that was the black and the white. The white can squish right down like this and squirt right through. The white goes, the black goes bang, 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 because the orifice is too small. This could squirt right down into little bits and pieces and go through. That's the difference. So here we have the black and the white. Let me just explain it to you one more time. All right, these are the two particles they have found. They know these are the two smallest particles that exist. There's this one here, and there's this one here. This one can get really glowy and give off a lot of, but it can also get down and squirt right down to a little tube. And that's what happens at the Venturi. So this is coming through the air at a zillion miles an hour, whatever the speed of light is in this particular case, and it can accelerate, which it did. All right, the wave normally was just like this. I can show you all this. I have all this stuff. I'm not going to do it again. It's crazy. I've done it a million times. It pulls itself right out of the magnetic wave. This had a big magnetic wave around it. It was a ball. And it's pulled itself straight forward, and it can squirt right through that Venturi. This is too big. It gets to the Venturi, and it goes bam, bam, bam. And what it does is it squirts the white right through the Venturi. It's like a battering ram. The black has all the mass, and the white has all the energy. And it comes out bam, 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 just like slapping it. And the white squirts right through there on a vengeance. You see it? Electron showers. This is the CERN's and Fermilab's picture saying a muon and electron neutrino are stuck together, called a diarac neutrino, di2. All right, the black and the white. When they hit this restriction, in their case it's heavy water, the muon goes on its way and separates from the white, and the white turns into showers. Precisely what you see. What is that? That's fission. That's when you break them apart. Before, they were fused together, and they are tightly fused. These are not They don't come apart easily. And when you do take them apart, that's electricity. This, my friends, is raw electricity right there. The black is gone. This has no weight whatsoever, and it has all the energy, all the burn. All right, and we separated them at the Venturi and kept the black from coming through strictly by the design of the Venturi. And because the white can get real tiny and squirt right through there, just like a string of beads, and just smashes in on the other side and turns into those showers. All right, you see how small that one is? It can get even smaller than that. It can get down to, I guess, almost nothing. And that one can get like this. These have a range. It's almost like a soap bubble or something, because they have no weight. I mean, literally no weight. This white is electricity. You see that white right there? That is electricity. I'm telling you, it's just exactly what electricity is. If you pump that white into a car, and only that white, let's look at this closely, that car would drive 500 miles. All right? So we got a car over here, and we're tapped right into that white. And that car has no energy in it whatsoever. It weighs 2,000 pounds. And we come over and we plug right into that white, and we fill that car up full of energy. And we take off, and we drive 500 miles. Well, it never changed weight, ever. When it weighed 2,000 pounds before we put the electricity in, after we put the electricity in, it's still 2,000 pounds. Drive 500 miles, still 2,000 pounds. We fill it back up again, still 2,000 pounds. No weight whatsoever. But all the energy is there. Now, how could you account for that much energy with no weight whatsoever? In a gasoline car, it takes 60 pounds of gasoline for a 10-gallon tank of gas. 60 pounds, 60. In here, 0. All right, so this is the way to do it. And it doesn't expand the atmosphere. It doesn't do anything. If we can use something like this, that would help. Okay, my friends, I'm just going to run through this real quick. I think I showed pretty clearly that the universe is saturated everywhere. They're just everywhere. The sun is emitting particles just continuously as it scrubs through the particles in space. That's why it's millions of degrees out here and only 10,000 on the sun. We also have that same problem. 3,000 degrees out here on our ionosphere and about 100 on the surface. 3,000 versus 100, millions versus 10,000, and there's no explanation for this. They want to mount a whole big new thing to try to figure this out. It's the scrub. It's the scrub, stupid. The temperatures are quite obvious. Hot, cold, hot, cold. The ground absorbs the electrons. So it's hot coming in, thousands of degrees out here. Then it goes down to minus 112 degrees. Then it goes back up to like over 100 or so on the face of the planet, and then the Earth absorbs, and it's just dipole, dipole, dipole. It's like these right here. It's like these ripples of gravity waves. And this is, like I say, this is, I don't know if I mentioned this, but it's taken from my cell phone, and I can't get any more information from the guy. I lost track of him, but it's pretty interesting. And this is obviously the moon. This blue means that the light waves are being compressed. All right, redshift means they're being expanded. Blue means they're being crushed. So I would say the moon is going this direction, forcing the visible light that we see in that spectrum to condense into the blue. And this is shifted more towards the red, maybe a little bit. It's hard to say. But all of these are magnetic fields, and they call them gravity waves. And they're looking for them right now. Here's what they show. Somewhere I had it around here. Yeah, this is what it is here. They just have artist drawings of it. They show a black planet and a white planet. To me, that's what it looks like. And then they're showing all these fields around, and they're entangled. Well, this is basically what a gluon looks like. The only thing is, the white has all the field. The black has no field. It doesn't emit, it doesn't absorb, it doesn't reflect, it doesn't do anything, basically. But it has all the mass, and the white is desperately wants to be attached to that black. And the black couldn't care less about being all balled up together and all by itself. So when you have big molecules, I believe the black all goes to the center, and then all of the white surrounds it in just huge piles of electrons, dipole electrons, which is the white part. So there'd be a ball of black. Well, here's my estimation right here. This is dipole electron flood theory. This would be hydrogen. Normally they say hydrogen is one big ball like that, one tiny, tiny, tiny electron. And they each have the same charge but opposite. Positive, the electron's negative. I say no, that's not true. It's made of this. So this is actually this. And every bit of these is a dipole. It's a black and a white particle. All right? It's just like a bar magnet. It's one of these and one of these glued together. They actually call them gluons. They know they're there. They call them gluons. They can see these things, but they're seeing it in a bunch of garbage. We can see it as it's happening in light. We can see the photons. I show you all the different colors and everything. And this changes a lot of stuff in science, chemistry, space, redshift, a lot of things. And everything is based on this. So there's a lot to think about here. A lot. All right. Is light always associated with heat, or is heat always associated with light? Or are they two separate things, or are they the same thing? Light is energy. Heat is energy. Light, when you see it, is radiated energy. Heat can be not radiated. It can be inside, but just sort of jiggling around a little bit. When you see light, it's serious energy. So light is a lot of energy. Heat is also given off when you give off light, but heat can be just sort of rubbing around a little bit. So here's what they say. Light is energy, heat is energy. I think we can agree on that. When a physical body absorbs light, it converts the energy of the absorbed photons into kinetic energy of its own atoms. That's because it's a chunk of matter hitting it. We call that mechanical energy heat. So the answer is yes. Light is heat, heat is light, and all mechanical rubbing of particles and frequencies of vibration is heat. And the hotter it gets, way up here, it burns you. You get X-rays. I mean, well, X-rays obviously are going to damage you. Gamma rays are going to kill you. Ultraviolet's going to give you sunburn and nasty stuff. Visible light is what we live in. Down here is just where it's like sort of warm and scrubby. And when you get below radio waves, you're down in this. You're down in this little jiggle, jiggle, jiggle. But up here, down here, it's just sort of rubby-dubby. And so you're pushing your electrons around back and forth, and you can feel there's a little bit of heat coming because there's a scrub. That's all it is. But when you get up here, you got a lot of scrub, you got a lot of heat energy. And the more light, the more heat, the more energy. That is just the nature of the beast. All right, this is why I'm upset with physics. They won't talk. Nobody in the physics realm will discuss this. This is light from a red pulse laser, and it's just beginning to accelerate. Otherwise, you wouldn't see these pulses. But it's beginning to accelerate because we put it into a venturi. So this is before it's accelerated. However, it's pushing all of these other particles out of the way. Every particle there is, gases, dust, they all have magnetic fields around them. Little tiny ones, you don't see them. Nobody ever really thought about it, but they all do. And when this has to push through it, they say, get out of the way, and they glow. Anytime you push or shove, you glow. So this glows much more because it's the one that's really pushing. These push back. I call it push to shove. These shove back, these push through, and they get shoved out of the way. They just get out of the way, and they do. They move. Now, what happened here? It's accelerating. You're not supposed to accelerate light. Well, I'm sorry we did it. I confess. All right, there's the particle. And it's, of course, it creates a wave because it's a particle. Now, the particle is these little bitty photons, but they have a big field around them. That's why they're pushing everybody else's field. Every particle has a field around it. So these here, and they're just sitting around, and they have particles, and they're gases. They're just sort of floating around. They're not really doing much of anything. And this pop pushes through it, and they go, rip. Anytime you push something, it glows. Now, so we're pushing like crazy here. Why is this accelerating? And you can see there's absolutely no question. There is no question that it's accelerating. This was the wave before. It was like this. And now it's accelerating. And there is actually the particle that I showed you, and I'll show you again. Well, maybe I didn't show you. There is the particle. All right, you see that little black and white one there? That's the photon, and that's when it's coming out of the wave. That's why they say wave-particle duality. Yes, absolutely. It's the field that creates the wave. The particle is what creates the field. So the particle creates the field creates the wave. Now, however, this is just like a jet fighter breaking the sound barrier. This is breaking the speed of light and pulling itself right out of the wave that would normally be light, but it's still accelerated. This is more than the normal speed of light. And light only has a certain, well, light does have a whole variety of speeds. This is just not right what they're talking about light. Einstein ruined science for 100 years. There is no speed of light. Light can slow down very, very slow. They've slowed it down to like literally a couple of yards a second, you know, I mean, just barely moving. And then they have it going, well, we have it accelerating. And not only this one, the blue really accelerates. The green is pretty fast too. But there's the particle. And here it separates. The black particle separates from the white. I will show you. And there they come back together. This huge amount of white explosion, that is energy. We started with almost no energy. We have tons of energy. We did nothing to increase that energy other than crush the fields, which is the same thing CERN's doing, only they're trying to hit them head on, and they just go like this and they go like that. 99% of them, every now and then they'll hit one head on. They think it's a big deal. Out of billions, they might hit 25 head on. Every one of ours is crushed through the Ventura. There's no escape. No escape, baby. Coming out of there is the Higgs fields. They see the Higgs fields too, but they just don't understand them because they're just seeing a pile of stuff. I mean, I'm serious. I don't mean to be nasty, but that's just true. They're using a ball like this and another ball like that, and they're coming head on, and boom, they got chunks of this and chunks of that and blobs of this, and they call it a particle zoo, and it is a zoo because it just doesn't mean anything. They have no idea what anything relates to. We started with light, so we started down here. That's exactly what we started with, 2 dipoles. Back to back, make light. One dipole, just one of these, which is a bar magnet, is nothing more than what we always thought was an electron. They call it a gluon, and that's fine. But it has a white and a black in that one piece. All right, and that does not want to be by itself. It wants to be glued onto something else. That's why they call it a gluon. All right, so don't forget, we started about the state of the planet. How does the carbon dioxide, and this is not true, it doesn't hold on to oxygens, and oxygens are the heat component. Well, it does to a degree, but that's not the problem. It's the expansion, and they won't drift off into space. Just by taking the carbon out, that's not going to make any difference whatsoever. If you expand, once it's expanded, it doesn't matter. You could take the carbon out, but you still got the expanded gases. And to take the carbon out, there's no way you're going to do it. And the more they burn, the bigger the expansion gets, and the more our issue becomes disastrous, which I don't think it's got to get much more. I think I've shown everything I need to show. And all I can say is we need to take this into consideration. This is not the problem. This is, they say carbon dioxide is Earth's most abundant greenhouse gas. It's a gas that absorbs and radiates heat. Well, that might be, but that's not the problem. It's the scrub. Unlike oxygen or nitrogen, which make up most of our atmosphere, greenhouse gases absorb heat, radiating them out into the surface and releasing them in all directions, including back toward the Earth's surface. Well, you're scrubbing through and the heat cannot get back out. We're being flushed with particles in an unbelievable cascade all day long. The surface of the Earth that's facing the sun is just, all of these are particles. They're not nothing. And once they break through our barrier, they're inside of our zone. And our Earth is going to have to deal with it somehow. Because once it gets through here, they don't go back out. That's not right. They're just not right. A very little bit might radiate back out, but it's almost nothing. That's why it's so hot. That's why it's so hot. 1,500 degrees Celsius right up here. It's just nothing but ions, nothing but electrons. They're being forced in. And we're pushing back out, just as the light was pushing back against everybody else. And then it gets to minus 80 degrees Celsius down here. This is just an unbelievable temperature change right on that layer because of the dipoles. And then because that gets real cold, this gets hotter. The hotter this gets, the colder this gets. The colder this gets, the hotter this gets. And then the Earth absorbs the Earth doesn't just take it for no, it heats up. The Earth heats up, the temperature heats up, the oceans heat up, the rivers heat up, everything heats up. But it will eventually sink into the Earth and you know, things can cool down. But the reason they're having such enormous hail and so forth is this is getting colder here. Right? The colder and the more condensed you get here, which more crush, and the more crush makes this hotter, which makes this colder and makes condense. That's why you get these huge hail. They're going to have basketball size. Well, some places they've got them like softball size. That's big. That's big. That'll kill you. It kills livestock and everything else. And it's going to, I don't see it getting any better. The more we expand, the more compressed our atmosphere will come, the more turmoil, the more, you know, turbulence, the more tornadoes and hurricanes and violence. This is the scrub zones. And up here it's sort of just spinning around because this is California here. So up here you're up at the pole. All right, this is not hard to understand, really, if you just understand it. We're scrubbing through space. Space is not a void. It's full of particles. All right? So thank you for listening. All right? Take care. I love you all. Bye. Okay, I think we just went through the more light, the more heat, the more energy, the more brightness. The brighter it is, the brighter the light, the more energy. This is just quite obvious. Now, this is the conclusion matches observation from the first tutorial. As we increase the electrical energy supplied to the lamps, that means the more energy, the more electricity, that's got more energy. They became brighter. So the more energy means that things become brighter. The color connection is not quite so obvious. Atoms and small packets of energy emit light. Now, this is from Kansas State University, but it's just anybody in their right mind fully understands that. The brighter something is, the hotter it's going to be. All right, I'm not going to say for sure anything, but I think this is worth taking a look at. I showed you that we can accelerate light. That's not accepted in the mainstream, but they won't discuss it. I showed you here the particles of light, and these are the red ones. They go very slow. The green go much faster, but they are the same particle. Right there, there's the green, same particle. And these are the neutrino values before they increase to their actual photon value. And that's what they talk about, the flavors. And the same thing happens with the red. See, the red has these different neutrino values, and then all of a sudden it shows up as a photon. And that's just prior to hitting the wall, which is the Venturi. And when it does hit the Venturi, it actually creates electron showers. Now, think this through. Just take your time, slow down. Take it easy. This is literally earth-shattering. What it is fission and fusion. What is fission? Fission means to break something apart, break it. And fusion means to have it come back together, or come back together, what it happens to be. They want to use big protons and big molecules and have them break all up and come back together and start a chain reaction. That's just not going to happen, I don't think. However, what we can do is when we put our particles through the Venturi, which is a very tiny slot, all of these fields are huge. And instead of hitting head on, which they try to do at CERN, and they just bounce off of each other 99.99999%. Every now and then they'll hit head on. But we force them to hit head in, and the restriction can be manipulated in a whole variety of ways. And all of those fields have to get into there, and the black can't get through. There's 100% white in there. 100% white. No black whatsoever in here. You see the little black balls? You would never see those. The only reason you're even seeing them here is because they sit on top of the white, obscuring the white. They don't reflect, they don't absorb, they don't emit, they don't do anything. And they don't care about being right on top of each other. You see them like in little globs over here? They don't care about that at all. The white, their fields push each other's fields apart. You see the little black ones here? You could just barely see them on top of things. But they're everywhere. They're everywhere, except here. What we have here is 100% raw white electron energy, which is what you power a car with. And it's just done through this Venturi, and that's called an electron shower. The muon electron neutrino, where the black and white particles attach together. When they slam here, the black can't get through. It's a fixed particle. It's too big. The white squirted through and turned into an electron shower. Now, electron showers are unbelievably powerful if you can do it, which we did. Now, here's what this was. I think Lawrence Livermore. I can't remember, but it was one of the big guys. And this is their visualization. These are the energy showers. These are the white low energy showers coming through, and then they create high energy showers. Well, high energy is high energy. High energy is high energy. So we started with low energy, and we ended up with high energy. Now, the muon, which is the black part is the muon. The electron part is the white. The black part just backed off, which is exactly what we saw. They come in and bang, 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 slapping, and the white just squirts through. This is really, I mean, it doesn't get any better than this. And you could vary the pulsations. You can vary the colors that are coming in here, the difference. They're showing all kind of different colors, like white, or I don't know. But we had different colored lasers. But this shows the energy that you can gain by creating these showers. That's the way I'm taking it. Now, if I'm right, I'm right. If I'm not right, I'm not right. But if I am right, think about this. We're coming through here. And if we had something that was like an absorption plate here, like a solar panel basically, and it took that white and shot it down into a battery, you could actually put that in a little tiny lunchbox like this. This is my dream, but it's a dream only because I can't do this. This was done with a very inexpensive pulsed red laser. This red laser right here, a Bosch GLM 115, I think is what it is. And it's just a red construction laser. And it was taken pictures of with a cell phone. All right? And cell phone CMOS, you can see this with. It's complementary metal oxide silicates or semiconductors, however you want to say it. But they're meant to pick up light pulses. And all this is light. So you have to have a ton of pixels, and every pixel in a CMOS has its own amplifier. That's the beauty. And all it does is absorb. It doesn't put any energy in. We're not putting any energy into that at all. We're just absorbing the radiation. And that's why CERN upgraded to use CMOS. Because before, they say every time we look at something, it changes. That's the observer effect. Well, they're adding energy. That's why it changes. If you're sitting out here and you let the energy hit you, not going to change. Anyway, something like this right here, you could have every different voltage, every different, you know, AC, DC, 110 volts, 220, whatever you wanted. USB, and just have a click, 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 anything you wanted. And in something like this, with a ton of these little photo receivers here, powered by little tiny lasers. I mean, these are tiny. These are just pinhead-sized things. And whatever light you got out of here and pushed down into your battery, see it coming through here? Here's a laser. The black can't get through. Just can't get through. But the white is getting slammed, pushed and pushed and pushed and pushed. So now it's coming through here. Now what are you going to do with it? Just let it go back together, which we did? Or are you going to intervene and say, hey, you come with me, we're going to go down and power this guy's car. Let's go into the battery for a while, and when he needs it, we'll shoot it off. It goes into the battery, no weight whatsoever. There's no weight to that. Zero weight, none, zero. You fill up a car, it weighs 2,000 pounds. You fill it up with electricity, it still weighs 2,000 pounds. You drive 500 miles, still weighs 200 pounds, 2,000 pounds. You charge it up again full, still weighs 2,000 pounds. Well, it doesn't have any weight. But it has a hell of a lot of energy. It's a very, very strange situation, but it is the case. And you can see it in an atomic bomb blast. When the first pulsation hits the house, it just vaporizes like this. And then when the black particles catch up, off goes the house. The black ones are the only thing that have any weight, because they're the only thing that have any mass. These don't have any mass, but they have a hell of a lot of burn, and that's exactly what you see in the low, you know, in the atomic bomb blast. They show it in very slow motion. You see the house just vaporize like this, and then all of a sudden, away it goes, and that's because the dark particles are the only ones that have any weight. And this is what you want to put in your battery, because it doesn't have any weight. It has all the energy. Now, I also want to make one last statement here, is that they're all talking about, we got to use electricity. Where are you going to get it from? First of all, you got to construct these giant windmills and all these things, or you got to build some new technology, or you know, the electric is fine, but something has to generate that electricity. Here, all we did was point a laser through a venturi. And if I'm right, it looks like it could very well be the gain of energy looks pretty extreme to me. If you can just put it down here into a battery, just keep charging, take a little nibble back and run the laser, it's just self-powered. And then whatever you need to run, you run your devices off it back to ground, and the whole thing just powers itself, and you can carry it around in a little lunchbox. It's electron dipole electron flood theory. I've had this for years and years and years, but I could never prove it until we actually did the light research and saw the particles being developed. And then you can't dismiss this. It's the same exact, identical same particles that Fermilab found. No difference whatsoever. The same particles. So, I guess that's all we're going to have to talk to for today, but I would like to be involved in somebody to try to see if they understand what they're looking at here. This is our atmosphere, and the more you blow it up, the harder it's going to scrub. It's turning hard. It should be sort of floppy and fuzzy, but now it's getting, the harder you blow up a balloon, at first it's a little bit floppy, and then all of a sudden it gets hard, and that's where we are at the hard part. Okay, this is where they're wrong. They're talking about particle showers. However, particle showers they're talking about are atomic particle showers, atoms. So incoming particles, to them, they're atoms, producing multiple new particles with lesser energy. So they're interacting and they're sort of dying out as they cascade through. That's fully understandable. Each of these then interacts in the same way, a process that continues until many thousands, millions, or even billions of low energy particles are produced. Low energy. In matter, they are going to be absorbed and by bouncing into things. Yes, they will become lesser and lesser of energy. I agree with that 100%. And when you're talking about matter. When you're talking about light, a different story. If you can intervene at the point where all the light is in this area, because this is the physics of electron showers. This is way down in the electron showers, not particle showers. Particle showers are big things. Electron showers, totally different story. However, in order to get those, they had to create these neutrinos, the electron and muon neutrinos. So they had to go proton-proton collisions, make hadrons and all kind of collision beams and axes and decay hadrons and flux energy neutrinos. And finally, they created neutrinos, antineutrinos of all flavors, and then got down to electrons and muons. Now, here's where we started with electrons and muons because that's what light is made of. So the energy of the neutrinos, there's these electron and muon neutrinos interacting with this little device they have, came up with a few 100 billion volts, electron volts, 100 billion electron volts, up to trillions of electron volts. That's a lot of energy from electrons and muons. The energy of neutrinos, of these particles, these tiny little particles, create. That's just astounding. So don't forget, they're talking about particle showers. Totally different situation. We're talking about electron showers. All right, pay attention to this. This is electron showers at CERN. They're talking about electron showers. All right, and this goes back to 2021, something like that. Anyway, these are the physics of it. I think I might have shown you something about this before, but proton-proton collisions. Anyway, it leads to the energy of neutrinos interacting with this gigantic monster machine they have here. And then they can see how much energy it gained. Now, so they're going through a whole bunch of stuff, the emulsion layers and da-da-da-da-da-da. This is the key, though. And the reason we can get energy, I think, from what I'm talking about, is the experiment, the setup, they showed shower tracking by emulsion films. All right, so they have films in here that when these beams of particles collide with these films, they shoot out all these different particles. Now, are they degrading the tungsten plates? It hits on emulsion film along 200 tungsten plates. This I don't know, but I can tell you one thing for sure. When our particles come in as particles of light, we know they're light, right? What they're doing is they're doing the same thing. They're getting down to neutrinos, which is the same thing as light. And then they're watching them collide. Now this is 2 centimeters. You see that? That's a pretty good distance. All right? And here they are all colliding and just going crazy. And that's what happens with electron showers. Now, if you can intervene when it turns into a shower, the shower, when you see it as white, it's white all by itself. Now that's what you want to do, is get that white. If you can get a hold of that white, like I'm talking about with this little device here, and harvest just the white, that's all you want. You should be able to walk around with something like that and be able to have all the energy you could possibly use. And no harm to the environment, no harm to you. They come right back together instantaneously. Very, very quickly. And the increase in energy is exponential. So, and you could have literally thousands and thousands and thousands of these little devices inside of here. Every one of them harvesting white juice sent down through what they call a bus bar, down through a photodiode into a battery, and the photodiode says you can go this way but you can't get back out. So once it comes down in, it gets slap, 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 slap from the pulse, and you could adjust these pulses and do all kinds of things. But the size of the particles is never going to change. All particles are the same. They're all exactly the same. All right, and I think I showed them here somewhere. Well, they're all like this. Black and white like that. And that's one of the gluons attached to another gluon. It's just like two little bar magnets. And when they come through the air, their field, which is huge, has to push everybody else out of the way. So they start to glow, and the guys that they're pushing into glow. as we saw here. And then, because it's a Venturi, that means it has to accelerate. Zip, takes off. It's just a very standard principle in physics. Accelerate. Venturi accelerates fluids primarily, gases. And light is nothing more than a fluid gas. It basically is. It's those particles that are shooting through the air. And they're literally, light is a liquid. It performs exactly identical to a liquid. No difference whatsoever. It's just like you shot your water through a hose and it came out the other side. All right, we want it right there. If we could get that, that would be very interesting to see if somebody could bring this to fruition. I can't do it. It's not my place anymore to do this. I got it to this point, and I'm as far as I can go with it, my friends. It's not a big thing to do this. Now, again, it's just a Venturi here, and a Venturi just means a very tight restriction. And the smaller the Venturi, the different curves and all kinds of ways you could design this. And then you need to have some kind of a device to harvest it. And they have all kinds of new chemistry now, perovskites they call them, which are thin film metal absorbers, is what you would have right next to the, you'd have to have it right here. As the light comes through, bam, it hits. And they're all different color, they're all different metals, basically. And they absorb different frequencies, because although you might be able to do it all with one frequency and one different type of absorbers, if platinum will take it or something, I don't know. There's a lot to work on here. But we know you have solar collectors, so we know we can harvest the sun. Now, we can make all kind of different types of lasers up to the extremely powerful. So we should be able to harvest it on this side, because what you're harvesting with a solar collector is only the white stuff. You're not harvesting the black stuff. You're harvesting only the white. And the white is hitting a certain type of molecule. It keeps the black pops back out and the white is allowed through, and that ends up getting into the solar collector and harvested. This is nothing but white, so we don't have to do anything at all. We just have to put the solar collector here. And you know, there's so much to do with that, or so much you could do, let me put it that way. It's all, as far as I'm concerned, that's done. That should do something. If somebody could play around with that, it would be very interesting. And you saw what it said about electron showers. Here it is right here. They come in low energy, zip, high energy. I was just looking at it. I had it online here. I think I got it. Oh, here it is right here. This is what happens. And all we want to do is harvest it before it gets back to the black. They got a big long thing on this. But we don't need that big machine. You don't need that big machine. Phaser is located along a beam axis, say 480 meters from the Atlas interaction point. And they're letting it hit through, literally through stone, I believe, to create this interaction, and then they pick up the vibration at the phaser. You know, I don't know what it is they're doing. It's just for experimentation, or they think they might be able to make a viable energy harvester here. I really don't know. But this is their paper about an experiment setup, phaser detector. They want to detect these phasers. Or, well, they're not the phasers. I don't think they're the phasers. They want to detect these neutrinos. All right, here's what they're doing. They're sending this high energy forward, and they're pulling off the charged particles with some kind of magnets, it looks like to me, which is the white particles. And they're continuing forward, dot, 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 dot. And you see what it says here? Neutrino, dark photon. So they've stripped off the white particles, and all they have is the black particles left. And it goes through 100 meters of rock to this phaser device, which is this phaser film setup, so they can see that these black particles are coming through, cascading through there. They can see these in these emulsions. Okay, so this is where the emulsion film is in here. All right, and they're seeing, this is right here, they're seeing them come through. Now what are they actually seeing? They're seeing dark matter. This is dark matter splashing out into this phaser machine. They call them dark photons. Well, it's like, you ever see these balls that go to a bang and 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 they go back and forth? It's the same thing here. It's going bang into that rock, and the dark matter will push against each other. And apparently they have to be in some kind of special rock, I would think. Some really tight rock, some granite or something. And the dark photon, the black ball, just keeps going bang like this way and ends up pushing into this phaser. And the phaser sees it as this cascade through this emulsion of stuff. And this is just nothing more than just hitting so hard here that it's going to vibrate out this side. And you've stripped off the white particles somehow, I think, with magnets here. That's what it looks like to me. Charged particles, they pulled them off with trillions of electron volts. And then the dark photons smashed into the phaser array here through this emulsion film, and then they could see them. And they make a big deal out of it. Well, I think it would be nice to be able to shoot the white particles through what we were looking at, which is this right here. This is not rocket science. It's just very simple, simple. That's what I like, is simple stuff. And you could have any kind of outlet you want, anything you want, if this works. But what you're trying to get is just white power. It's just white. It's just nothing but power. It's just nothing but energy. There will be no weight to it whatsoever. And you should be able to plug right into this and have either a storage battery in here of some sort, or you plug right in and just let it feed into it. It depends. I don't know how much energy you get out of it. But you should certainly be able to let it sit there and keep charging batteries if you can get excess energy. And I don't see any way you can deny that that has less energy than this. So if we can take just this white, which is all you want, that's all you want, and then power whatever devices we want. Portable, no grid, carried around. All right, so global warming, they just don't understand it. And you know, I don't mean to be rude and nasty, but I've been, so long trying to work with this, and not a single word from anybody there. And it's scrubbing harder and harder. You cannot blow up the atmosphere with burning and more. Pump, baby, pump. No. It's not just going to float off into space. It will not. It's being forced down. That's why the scrub is so intense. We have hurricanes and floods and tornadoes and all these different global patterns that are just terrible. And that's why they've opened this site, is to forecast, here's we're going to have this going to be destroyed over here. You're not going to have any crops next year. This place is going to get cold. It's always been hot. This place is going to get hot. It's always been cold. Did you know that Antarctica is the coldest it's been? Nobody talks about that. So why is Antarctica so cold? And why is the Arctic region, the North Pole, so warm? All right, we talked about dipoles. That's the reason. This is going to get warmer, the bottom one's going to get colder, and that's exactly what's happening. All right, it's a lot more to this than they have been thinking. And I don't know whether they're just not thinking, or they're just not competent, or I have no idea. But I can't believe that, well, let me just leave it with that. I don't want to be nasty. But there's got to be somebody there that's going to start thinking. It's got to happen sooner or later.